Welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we are going to look at gradients, and specifically, we'll look at different types of inputs we can give to a gradient method in TensorFlow. So we'll look at what is gradient, what is a gradient tape, and different types of inputs. So a gradient, you can think of it as slope of a line. As so, the idea behind this is we can use the slope of the line to take small steps in a particular sequence of calculations. So we can increment a value by very small increments to achieve the final objective. So let's say if you are trying to maximize something, then to go from here to here, we can take very small steps along this line and then reach here. So this is a very vague explanation, but here is example where we can calculate the slope of a line. If we have these 2 points, 2, 3, and 6, 6, just change in x divided by change in y, and that's the gradient or slope. Of course, in machine learning or deep learning, this gradient that is calculated is based on derivatives. We are not discussing that here, but the main concept is gradient is think of it as slope. Now let's get into Colab and start coding. So here we need to first import the libraries. So let's do that. Import libraries, import. So the first library we'll import is NumPy as in P. Then we need import TensorFlow as TF. So these are the two that we need. Now computing gradients, the way this works is, let me write down the heading here. And we need this to be in a markdown. So I'll create a text box. Okay. So in neural network, what we have is this a forward pass, and there are weights calculated during the forward pass, and then there is a backward pass. And again, during backward pass, gradients are calculated, and then together this helps us arrive at a prediction. And so to enable this calculation of gradients, what TensorFlow has is an option where we can store the values. So there is something called as a gradient tape, and what TensorFlow does is it records. So TensorFlow records calculation on in forward pass, and then it uses, and this recording is done onto a gradient tape. So this is a conceptual idea, and then it uses this tape to calculate gradients in backward pass. So this is how it works. And so the importance of gradient tape is conceptually you can think of it as recording. So if there is a calculation going on during forward pass, that is recorded on the gradient tape, and during a backward pass, those calculations are used to find the derivatives, and those derivatives are propagated in the backward pass. And so that's the importance of gradient tape. Now gradient tape has different types of inputs. gradient command has different types of inputs. So let's go through each of these one by one. So let's first look at input that is a scalar, and I'll create another section here. So for scalar input, we'll supply just a value. It won't be a tensor. It won't be in a tensor form. So get started. Let's record some operations onto a gradient tape. And for this, what we'll do is we'll first create a variable. And as you've seen in previous video, to create a variable, we need to type tf.variable. And here we'll just use a float value of 2.5 because we are working with a scalar quantity. And then next step is to record. So for record, this is the format we type with tf dot gradient tape as tape, and then we need to specify a relation between x and y, and in this case we have y is equal to x squared. So that's the relation we are using, and this is the computation that is done during the forward pass, and the values are stored in the onto the gradient tape, and then in the backward pass those values are used to find the gradients. So let's print y, which is equal y, and also let's print the tape. Type print type tape, and we type type tape. So when we run this, here we can see that this is the output of x squared. So we had x as 2.5, so square of that would be 6.25, and then the type of tape, it's gradient tape, as you can see here. So we have recorded the values on tape. Now we need to use them. So let's do that. Now calculate the gradient, and usually this is loss, that is to say how far the predicted value is from the actual value, and then manually this would be an equation for derivative that is calculated like this. We have y is equal to x squared, that's the computation we are working with. So what we would do here is do dy by dx, and this would be d x square and then dx, and then we have dy by dx is equal to 2 times x, and in this case dy by dx is equal to 2 times 2.5, and therefore the output that we get dy by dx, that is a slope, is 5.0, and that's what we are going to try to calculate using the gradient tape that we created up above. So let's call this gradient of y x and tape dot gradient y comma x. And now if we get the output grad underscore y underscore x dot numpy, run this, we get the output which is 5. And with this, then we now have the first method where we calculated the gradient tape and then calculate the values for the gradient using that tape. Next, let's look at how we can use a tensor to perform the similar type of calculation. So now we'll create another heading and let's call this tensor. The input here is a tensor, and for this a common equation for most common equation in a forward pass is y is equal to mx plus b if you know the equation for the straight line. So here instead it's x dot w plus b, where w are the weights and b is the bias. And here the dot represents a dot product. With this, then what we can do is, in generally in neural networks, the weights and biases are randomly initialized in the first iteration. So we have the weights, we are going to randomly initialize it, and the initialization again will use the commands from TensorFlow itself and not NumPy. And here we are also creating a variable in a sense called w. So tf dot variable, and here we have tf dot random dot normal, and we are specifying 3 by 2, and we can also give this a name. So we can give this variable name w, and similarly we can calculate the bias which is b, and again this would be tf dot variable, and we have tf dot random dot normal, and or here we can initialize them to 0. So tf dot zeros 2 comma, and we'll keep the data type as float tf dot float 32, and we'll label this with a name b. So those are the two items variables we have created. Let's print these. Print w, and this is w, and then let's print b, which is right here, and so that's the b we have. So we have the randomly initialized variable, which is 3 by 2. We have 3 rows and 2 columns for w, and for b we have a shape of 2, and the values are initialized to 0. So this is what we have 0 0. Next, let's create our input. So we created the weights first, initialize the weights for w and b. Now we need to create this input. And for creating the input, it can type input features x. Trying to see if I can zoom in on this screen, so maybe you'll be able to see it better. Okay, and here we have x is equal to tf dot constant, and we can create float values 1, 2, and 3. So that's the tf dot constant. And remember that this what we created is a tensor, and it's not a variable, it's a constant tensor. Now we can use that input, record operations. So we are going to record the operations on a gradient tape, and here we can type width tf dot gradient tape and persistent is equal to true. I'll explain what that means in a minute. And then we have y is equal to x at the rate w and plus b. So here the at sign that we have, that is simply a sign for dot product. Next we calculate the loss is equal to tf dot reduce mean, and this is y squared. So the reason we set the persistent is equal to true is because the idea is that the gradient tape, after it is created, when we try to calculate the gradients, it can be used once. So the second time it's not available for use. Therefore, if we set the persistent is equal to true, then the gradient tape can be used multiple times. So let's run this. And so we now have all this calculated. Next thing we need to do is calculate the loss based on the gradient tape we have. So calculate the gradient of loss, and in this case this would be, if we look at the different derivatives, it would be something like this is, and this is equal to, and this is what we are denoting as d loss of dw, and then d loss with respect to dB. We are referring to this as dl underscore dB, sorry, dl underscore dB, and this would be dw. So for calculating the gradients, then we are going to use a tape dot gradients, and here we specify the y, which is in this case is loss, and the x, which is the input, we specify w and b, and this would return two values, so we'll put them in a list, and this is dl underscore dw, that's the w slope with respect to weights w, and then we have the slope with respect to the bias b. So that's what we have, and then we can print the values. So dl dw, and this is dl underscore dw. Next we have print dl db, and we have dl db, and when we run this, gradient type has no attribute gradients, and that's right, we do not need a s there. So this is the final output from the gradient after using the gradient tape. So we have the slope or gradient with respect to the weights, and we have the gradients with respect to the biases dw. Now, in addition to using the tensor as an input, so here we had a tensor as an input, we can also use a dictionary. So let's see how that would work. I'm going to create another cell here, and let's call this input. In this case is dictionary, and it's the same concept. So why don't we copy the code from up above, copy all of this, paste it here, and this part stays the same, because we are initializing the w and b, and the recording part, again it stays the same, where will where we are, and so let's see, this is the recording part, and recording part again we have x at the rate w plus b, so we keep that the same, and our x also stays the same. What we are going to change is the input for my variables. So W and B. So let's do that. I'm going to add lines here. We'll create a dictionary, and my underscore vars is equal to W, and then we have B, and that is equal to B. So with this, then we can use this to calculate the uh, gradients. So for that, we can say gradient, and grad is equal to tape dot gradient, and here we can specify the loss that we have above, and then specify my underscore var variables, and then we can print the output. So print, the first one we need is get a new line dl underscore dw, and we have that as grad w. Print, the next one is dl underscore db and grad, and this would be b. So when we run this now, we get the values for the gradient with respect to w, weights w, and gradients with respect to the bias b. The only difference here is that the input that we had here while calculating the gradients using the tape was a dictionary, as you can see. The next item we'll look at is how we can calculate gradients with respect to a model. So we'll create another heading here. Gradients with respect to a model. And for this, the model that we have is layers. Layer is equal to tf dot keras dot layers dot dense, and we have 2, and then activation is ReLU. So that's the layer we have, and then the input will create a tensor. X is equal to tf dot constant, and here we can specify 1 as float, 2, and then 3 as floats. The next step is to record, and for recording we use the same method with tf dot gradient tape as tape, and then we are working with a forward pass here. So forward pass, and so we have y is equal to layer x, so that's calculated, and we can get the loss is equal to tf reduce underscore mean, and that's y squared. So once we have that, now we are ready to perform the calculations for getting the gradients out. So gradients, so we calculate the gradient grad is equal to tape dot gradient loss, and then we have layer dot trainable variables, and those are the variables we are getting from the layer. And what trainable variables means is, if you remember from previous video, when we are talking about, let's put a note here, when we are talking about tf dot variable, in this case the setting, it can be set to, we can set this as trainable is equal to true, and so what this is talking about is the same trainable idea with the variables from the layer. So trainable. So now when we try to print this, so print type gradient, and then we print the type of gradient, and next let's print the gradient themselves. So grad, a new line, and we have gradients. So we'll see in the output that here we have the type of gradient. So what we get out in the output is a list, and within that list we have two items. The first one is a tensor, rank 2 tensor, because it's 2 axis, it's this tensor. And the second case we have on this particular value, which is scalar value of 2. So those are the calculations from when we are using model as layers from the model as input to the calculating the gradients. Now there's another point to note here is that let's look inside what's in the layer dot trainable underscore variables. So for var g in zip layer dot trainable underscore variables grad. Here we can print f, and we can print the var name, and then we can also look at the shape, and again the shape here, put d dot shape, and so that's how this is. So when we run this, we see that the name of the variable is dense. That's the layer we had, dense layer, and the kernel 0. So this can be thought of as the W that we have, which has a shape of 3/2, and then the second one is bias, which is scalar value of 2. So essentially what we have as an input with layer dot trainable variables is nothing but W and B that we saw earlier. And we can look at the we already looked at the values, but we can look at them again. If I copy this and run this cell, we see that these are the initialized values for W, and these are the initialized values for B. So this is the bias, and that's the kernel. And again, this, if we look at the type of layers.trainable, look at the type, what this is, it's a list. As you can see, it's a list. So we have this square bracket here and this square bracket right here. Now, okay, so with that, let's also look at, we already looked at what the gradients look like. Now let's look at next part in the coming video, where we'll look at how we can control the recording on a gradient tape. So in this video, we looked at how to calculate, how to record on a gradient tape, how to use different types of inputs such as scalar, tensor, model, trainable variables as an input to calculating the gradients. Please like, share, and subscribe. I hope to see you all in the next video. Thank you.